there are two parts. One is confirmatory factor analysis part, or you can say that is the CFA part. Okay, this is one part. That means the measurement model. And another part is path model. Okay, or the structural model. These two parts are there. And under both parts, there are some steps. Okay, so under the part of confirmatory factor analysis or the measurement model, we have discussed the first part, model building. Then we have also discussed the second part, model identification. The third part, parameter estimations. And the fourth part, model validation, that we are going to describe in detail today. And earlier also we discussed the different fitness indices, okay, to test whether the model is fit or not. That means whether the it has the capability to reproduce the data or not. That we have checked the fitness of the model. So now we are going to start the model validation. So in model validation, you can see that there are 4 different things we can observe in order to check the model validity. One is convergent validity, number 2 is discriminant validity, number 3 is nomological validity, and number 4 is phase validity. Okay. But in our discussion, we will be restricted to convergent validity and discriminant validity. That will suffice the requirement. We will not discuss about nomological validity and phase validity. That is not required. So under convergent validity, there are 3 approaches: factor loadings, average variance extracted or construct reliability, and the third one is Cronbach's alpha. And then the discriminant validity that we will also describe. Okay. So first, you can see that it is saying that the first thing is factor loadings. If factor loading lambda is greater than 0.5, it means 0.5 whole square is equal to 0.25, or 25% of the variance of the variable can be explained by the factor or construct, which is minimum requirement. If a variable is not even 25% explained by a construct, it cannot come under the construct. So what I am trying to say here, that suppose I am showing you one diagram that will be easier for you to understand. Yes, you can see that in this diagram, I am enlarging it. Okay, you can see that there are 4 different constructs you can see. One is human resource practices. This is training practices. This is organizational culture. This is work engagement. Okay. Now, under these particular constructs, you can see that there are several variables. These constructs are unobserved variables, and these variables are observed or manifest variables, but this is latent. Now, suppose if you see that some particular variable, you can see these loadings, the loadings are there. Okay. So if you see that some particular variable, okay, it is even not the loading score is not 0.5 or less than 0.5, then you can neglect it, okay, unless it has got some theoretical justification behind it. You can just simply drop it or you can neglect it. But since in structural equation modeling, basically you are performing the confirmatory factor analysis, you cannot neglect it, because from the literature review you have described that there is the proper justification behind it. From literature review you have already done that, so you cannot neglect it, but you can at least say that the influence is very less, because that if the loading score is suppose 0.5, then if you make it square it will become 0.25. okay, that means only it is capable, the construct is only capable to explain the 25% of the variable, which is very less. Okay, so ideally speaking, that construct should not, that particular variable should not come under this particular construct. Okay, but since you have already taken it, you have already considered it from the literature review, you cannot neglect it, but you can simply say that this particular variable is very less influential of, because of this construct of organizational culture. Okay, so this is the one type of thing. Then another is the average variance extracted, okay, or the construct reliability. Average variance extracted is a measure of the amount of variance that is captured by a construct in relation to the amount of variance due to measurement error. It means it measures how much average variance is explained by each variable for the factor taking into account error variances as well. Okay, so you can see the formula for the average variance extracted. It will be clear. Summation of lambda whole square divided by summation of lambda square plus the error variances there, summation of error variance. That means when you are going to calculate the average variance extracted, suppose the average variance extracted you are going to calculate, suppose here it is lambda, this is C1, C2, these two are constructs, and under C1 construct there is there are variables like V1, V2, V3. Under C2 there are variables like V4, V5, V6. Okay, and this is the loading score lambda 1, lambda 2, lambda 3. These are the loading score lambda 4, lambda 5, lambda 6, and they have a correlation of R. Okay. So the how can we calculate the average variance extracted? You will simply sum it up, all these lambda 1 square plus lambda 2 square plus lambda 3 square divided by all these lambda square, lambda 2, lambda 3 square plus all the error variance square. So you will be able to find out the average variance extracted. Okay, now you can say that why this is important, average variance extracted, why you need to calculate this. Because ideally speaking, this average variance extracted, it should be greater than the small r square. I have already said that r means this is the correlation coefficient. Okay, and what is r square? R square means this is the coefficient of this is determination, r square value. Okay, so here you just notice that suppose your r value is small r, suppose you think that your small r is 0.6. Okay, and suppose your the average variance extracted that you have found for the construct C1, it is suppose 0.3. Okay, now if r is 0.6, then r square, that means the variance will be 0.36. Okay, now your average variance extracted, it is 0.3. Okay, what does it mean? It means if this r square, it is higher between C1 and C2. Okay, that means 36% of C1 can be explained by C2. That means these two variables, which we are terming as constructs, they are much more related to each other rather than these variables which are under this construct. Okay, are you getting the point? What I'm trying to say, that how much close these variables must be very closely associated with this particular construct. But if your r square is greater than the average variance extracted in this case, then it is seen, we can see that this is more oriented to C1. Okay, because 36% of C1 can be explained by C2. More variance can be explained by this. Okay, so that is another that is one problem. So average variance extracted should be, it should be greater than the r square. Okay, so this is another thing. That's why the concept of average variance extracted, it has come. Now there is another concept, that is Cronbach's alpha. Cronbach's alpha is also similar like that. Cronbach's alpha is a measure of internal consistency, that is how closely related a set of items are as a group. It is considered to be a measure of scale reliability, and it should be equal to or greater than 0.7. This is the equation of the Cronbach's alpha. Very easily you can calculate Cronbach's alpha using SPSS. Okay, software. So what you will see here, if your Cronbach's alpha, if the score is 0.7 or more, you can conclude that the internal consistency is very good. That means you are basically checking that how closely these variables are related to form a group, which is group or this construct C1. Okay, so that is you are measuring through Cronbach's alpha. Okay, this is another thing. Now we should go for the discriminant validity. So what is discriminant validity? I am just going to tell you one example, the idea will be clear. here you just see this matrix, this table. So this table you can find in my paper that I showed you earlier, that I had four constructs: environmental proactivity, manufacturing based operational practices, non-manufacturing based operational practices, and financial performances. So these four constructs I had. So under EP, I had got some variables, manifest variables. Under MOP, I had got some manifest variables. Under NOP, I had got some manifest variables, and under FP as well. Okay. Now you can see that EP1, it is very highly loaded onto EP, but it is less or weakly loaded onto MOP, NOP, and FOP. This is the highest value. Similar in case of MOP, the highest value is this. In case of NOP, the highest value is like this. For FP, the highest values are you can find here. So it is clearly showing you that it is evaluating the discriminant validity. That means one particular variable is highly loaded onto that particular construct from which or under which it is derived, and it is weakly loaded onto the other factors or other construct. That is actually the case of discriminant validity. But at the same time, whenever you will perform discriminant validity, automatically you will get some sort of information about convergent validity as well. Okay, because where it is in for which particular factor it is highly loaded, that is also you can see. Okay, so as at the same time you can see this, check the convergent validity, but it is technically it is speaking, or it is, we term it as discriminant validity. Okay, so here this is the end of the measurement model, okay, or the confirmatory factor analysis model. So after this we will start the path model, okay, or the structural model. Okay, so this was the example that earlier we gave. Okay, so we told that these are the independent variables, these are the dependent variables, these are known as exogenous variable, these are known as endogenous variable, these are the manifest variables x1, x, y, and these because these are observed, you will be collecting data based on these variables, and these variables you cannot observe because you will not collect data you cannot collect data of these constructs. Okay, the constructs are represented by circles, or you can also say these are the unobserved variables, and or the latent variables, and these are all the manifest variables which are represented by the rectangles. Okay, these are manifest variables, you can directly collect the data, and all these are error terms. So now in first case, when you have gone through the measurement model, based on the measurement model equations, you have found the values of the lambdas or the loadings you have found. It will be automatically, it will be done by the software. Okay. Now your intention is to find out the values of these gamma 1 1, gamma 1 2, gamma 2 3, gamma 2 2, beta 2 1. These path coefficients you will be finding right now from the path analysis model. Okay, so here also you need to do the same sort of things. These are the equations for this particular case. These are given. Okay. So it's the same way how I have previously told you that how these equations are actually derived. Okay, how one particular variable is influenced by others, based on that these equations are written. Okay, I have already expressed it in the earlier class. So, but I have taken the different example for that. Here the different example is given. I told it for this case, but here another example is given where there are 9 variables. So similar, here also you need to check that total number of parameters to be estimated. That here you can see that the total number of parameters to be estimated, that is 30. And how many data points are there? Since there are 9 variables, you will put in the formula 9 into 9 plus 1 by 2. So 45 is the total number of data points. So the number of data points is greater than the total number of parameters to be estimated. That means this is over identified model, and we can find out all the estimates. Okay. So automatically it will be done by the software. Okay. So this based on the path model equation. So similarly, you will, the models, the parameters will be estimated. That means the path coefficients will be estimated. Okay. So then you need to again check the fitness of the model, just like the measurement model. Again, you need to check out the structural, the fit indices for the structural model. You can see that chi-square by the degrees of freedom, the root mean square, residual goodness of fit index, normed fit index, comparative fit index, incremental fit index. So different fit indices you will find, just like the fit indices that you have observed in the measurement model. The same fit indices you can also, you will have to calculate for the structural model as well. And different fit indices you will find for the structural model or the path model. Okay. So once you find out all those things, and if you find that your fitness it is okay, then you come to an end of the structural equation model. Okay. So this is the basic of the structural equation model. So I would like to repeat it once again, that in structural equation model there are 2 parts. One is the measurement model or confirmatory factor analysis. Then another is the structural model or the path model. First you go through different literatures, you identify some variables, you identify what could be the constructs, you identify which particular variables will come under which particular constructs. Okay. Based on that, and based on the your uh, domain knowledge or skill, you form the hypothesis, okay, between the unobserved variables, and you get it verified by your teacher or supervisor or the experts through workshop or through whatever be the bin. You verify it and you build the model first. This is the first step. And after building the model, the second step is the model identification. We have discussed it earlier, that how the model identification is done, whether it is over identified or under identified. Okay. So we prefer the over identified model. Okay. And after the model identification part, we estimates all the parameters, Okay, and that is actually that is automatically done by the software based on the measurement model equations. Okay, it is, so we estimate different parameters, we then analyze the fitness of the model. Okay, we analyze the fitness of the model, whether it is fit or not. Okay, and after that we verify the model. Okay, the verification is done, and then we uh, after completing the confirmatory factor analysis, then we start doing the path model, or the structural model. Here also, like just like the same things that we have done in case of confirmatory factor analysis, the same kinds of things we do here. Here also we check the model identification is done, the parameters are estimated, the fitness of the model, those things are also checked. Okay, and finally we do one process which is called bootstrapping. Okay, but that we will discuss later. Okay, we will discuss later about the bootstrapping model. Now let's check another concept of structural equation model which is very widely used, that is known as the mediation and the moderation effects. Okay, this is very crucial. Okay, because usually you need to make such a paper that is preferred actually. Suppose if you do just nowadays, if you do just suppose simple uh, 2 or 3 hypotheses if you propose. Okay, and suppose this particular construct, how it is related to this particular construct. Okay, whether it is positively correlated or negatively correlated, if you just check these things, okay, that will not suffice. You cannot convince the reviewers. That is the problem. The reviewers will ask you that reviewers will tell you that there is nothing in the paper, just some 2 or 3 hypotheses have been proposed, straightforward hypothesis, and this is a very simple kind of paper. So in most of the reputed journals, those things are actually not granted. Okay, the editors, they also reject based on the proposal of the reviewers, and reviewers, they don't like it even. Okay, so there must be in your paper the mediation or the moderation effect. This is actually very useful because you need to show that I have done a lot of things. Okay, though technically speaking, it is, the idea is wrong, the idea is not good. Okay, but still it happens. Okay, I have observed it, it happens. So what could be done? So what can be done? What we can do? We can include also some mediation and moderation effect. Okay, so let's take a look at the idea. A mediator mediates the relationship between the independent and dependent variables, explaining the reason for such a relationship to exist. The mediation effect is only valid when it has a higher significance level as compared to the direct effect. Moderation is a way to check whether that third variable influences the strength or direction of the relationship between an independent and dependent variable. Though it depicts the relationship between the dependent and independent variable, however, the moderator itself is not influenced by the independent variable. And what is the key difference? A moderator does not change as a result of your experiment, whereas a mediator changes when your independent variable changes. Mediator examples from social science: like anger, fear, perceived social impact. And moderator examples are like age, gender, personality traits, level of education, political beliefs, etc. Okay. So take a look at the example. This will be very easier for you to understand. Okay. Here, I have given the example of supply chain practices. Okay. I have given the example of mediation effect and as well as the moderation effect. Okay. What is the mediation effect? Just have a look at this one. There is operational under the construct operations capability. There are some variables like manifest variables like new product design and development, just in time, total quality management, like this. In supply chain, under supply chain practices, there will be also some manifest variables. Those have not been shown here. Under farm performances, there will be also some manifest variables. Here those things are not shown. But now, how, simply speaking, if you want the straightforward relationship, how you will look that how operations capability affects or influences farm performance. Okay. Now, in between, you suppose you are proposing one hypothesis that operations capability is positively related to farm performance. Okay. Now you are proposing another thing, that operations capability with the help of supply chain management practices, it is positively affects the farm performance. That means there is a mediation effect. That means the supply chain management practices, it is an addition, it enhances the farm performance. Okay. If you only, if there is operations capability, it will be, suppose it will be improving the farm performance. But if you incorporate the supply chain management practices in this relationship, then the farm performance will be much more improved. Okay. So this is actually known as the mediation effect. But if the mediation effect is it is more than this effect, okay, if this effect is more than this effect and also it is significant, then only you can say that there is an importance of this moderator. Otherwise there will be no importance of this moderator. You can very easily understand that, suppose mediation means it will mediate the relationship. Okay. But if there is no effect, no meaningful effect of this mediator, okay, then there is no importance of this thing. Okay. If this relationship is not significant, or if this the path coefficient, if it is less, then usually it is not it is neglected. And there is another thing that is called moderation effect. Okay. In case of moderation effect, you can see it is less than 1 minute now, so we can rejoin again. Okay. So in case of moderation effect, you can see that time, relationship quality, national culture, so these things are given, okay, between the dimensions of SCI and farm performance. So this is known as moderation effect, because this relationship is influenced by these factors, okay, or so suppose these variables. Okay. But what is the difference between these two things? The difference is that here you can see that the supply chain, it is influenced by the operations capability. That means this is the dependent variable, this is independent variable. But the mediator, it is influenced by the independent variable. But in this case, moderator